we respect everyone. It is a privilege just to join you today to celebrate this moment, which is which speaks to me. I said to Tate Magai this morning, Tate Magai, yesterday was my birthday, so I'm on a celebratory mood. Why should I come here and drive 2 hours to Mpumalanga? But I didn't question it also because I'm a servant. I'm here to provide a service. And that's something that fulfills my heart. And I do it with a smile. So that is the reason why also I couldn't complain. I just woke up. Babalas from coffee. I love coffee so much. So that is why I'm here. So we are here as the Sasol Foundation supporting this great initiative and supporting mainly the Highveld district because we want the district to perform very well. This program reflects the Sasol Foundation's commitment to improving the quality of education and creating opportunities for young people to succeed. And through our pledge, the reason why also I'm emphasizing that is because, you know, one question that we always get is that why are we not having a lot of learners around a Sasol plant working day? Or they don't even know what is happening in the plant. But most of them tend not to. They just are very ignorant. Some of them, the parents are working in the plant, but they don't know what the parents are doing. You don't even ask your parents what they are doing. But then launching this program also tries and encourages that physical science and mathematics has to be strengthened. And more especially in all angles. You are already in grade 10, which is the most important grade, which is the most neglected grade. I always say that because we focus on primary school, intermediate, somewhere grade 8 and 9. When we get to grade 9, we say kids have to select subjects. They select subjects. You get to grade 10, the support goes down. 11 and 12, we all wake up. And I'm saying we because educators, the whole education support system does that. We are not aware that we're doing that. But what is this program focused on? It's focused mainly on grade 10s, which is what makes it even more special. 180 grade 10s, 180 distinctions. Are you all going to get distinctions? Yes. You're already getting distinctions, aren't you? Hey, Baba, hey. But you'll get there. Don't worry, we are here to help you. The reason why I'm making a promise that we are here to help you is because there is an element of hand-holding. There is an element of mentoring. There is an element of coaching. But throughout all that, the parents are here and they will hear that we are not saying do not wash dishes. We are not saying do not clean your room. You've got to balance your life. That is the most important thing. So through the leadership from Osizweni Science Center, who is our implementing partner, the learners are going to receive academic support. I've said that. They are going to receive guidance. They need to build confidence, improve their performance, and prepare for success in grade 12 and beyond. We are not just preparing you to get distinctions and then increase the rate of unemployment in the country. But we want you to focus and know what you really want to do. Sometimes as parents, I'll go to the parents now. Sometimes as parents we tend to say, I want my child to be an engineer because I failed in being an engineer. Or I want my child to be a doctor because I failed in being a doctor. But my child wants to be an motor mechanic. Or my child wants to be an entrepreneur. My child wants to be something that is out of, or maybe you don't know much about it, but we still need to support them. So to the learners today, this is your opportunity. You need to work hard. You need to stay committed and make the most of every lesson. The effort you invest today will shape the future you dream of. That's very important. I became a teacher. I'll give you a simple example. My dream was to be a doctor. 1991, when I matriculated, I'm giving out my age now. My dream was to be a doctor. I had very good grades from a very good Catholic boarding school. But I wanted to be a doctor, but I ended up not being a doctor. But I still pursued science. I'm a BSc graduate, majored in chemistry and physics. So that is important. But after that, what did I do? I said, I'm looking for a job. Do I really want to be mixing chemicals and what? Not that I'm undermining it, but that was not me. Standing behind beakers and coming up with solutions. I was already having problem-solving skills. I was having all those things. But I said to my dad, Vet has accepted me, and he thought maybe I'm going to lecture. Kante was going to study. And I said, don't worry about fees. I went to the bank and I took a study loan. You see? Because I did that because I wanted to get something. Having a study loan is like having a Woolworths loan or something like that. Because you are going to get something that nobody's going to take away from you. And I did that, and I studied and I pursued education. After that, what happened to me, went through astronomy, space science and everything, and I became at Sasol. I went to Sasol. What am I doing now? Still promoting education. Why? Because it's important. Just yesterday, I met one of the learners I taught, and she recognized me, and I taught her 24 years ago. And she was like, ma'am, and you know what it does? And one thing I always say is that being an educator is one of the professions that people are proud of their learners. There is never a time a teacher will feel threatened by the success of their learner. But the teachers always celebrate the success of their learners. You are never in a position where you are going to say, I am still a teacher, but my child is now a doctor or an engineer. You actually say, ooh, I'm proud to have produced an engineer. Why I'm saying that is because I want you to think as you go through this process, as you are going to be mentored and coached in various careers, you need to see yourself. You need to say, what is it that I want to do? Do I really want to be a medical doctor? Or do I really want to be an engineer? What does it take for me to understand that? Do not be like an example that Ndademakai made now. Not understanding what a career means. Do not be like other nurses. I'm sorry parents if one of you is nurses, but I hope you are the good nurse. Don't be like other nurses where our kids are scared of going to the clinic to access the basic services that they are entitled to. Because when they get there, you tell them how young they are, you tell them what are you here to do, where are your parents, did I send you to go do this? No. That means you did not do your career profiling properly. You've got to be a servant. You've got to be compassionate. If you feel that this is not for me, go and be a computer scientist. Go and be an analytical chemist. Sit alone in the lab and work alone and don't work with people. So as I close, to the educators that are here, thank you very much for your dedication. Continue nurturing our kids. Continue nurturing their excellence and inspiring the next generation of scientists, engineers, and innovators. Produce those kids, nurture them as they are here. We don't want any one of them to be dropping out. We want to, I know teaching is stressful. You are more of the second parent because you know the kids more than their parents. You spend more time with them. So continue doing that, good job. Understand which other areas to access if they need psychosocial support. Our kids do not speak. Our kids speak to ChatGPT. Our kids speak to TikTok. Our kids have got friends in their own bedrooms, but that we don't know because they have gadgets. Take away the devices and make time with them. Have that time. I know you love your devices so much. Parents have got to know that they take away the devices and have that time with you. Most of you rely on devices and not on your teachers, and you still underperform in school. So I don't know, because it's not like that. You've got to remember that your parents were once your age. Finally, just to say to the parents, your encouragement and involvement are essential. Together we can support our learners to reach their full potential. Not a lot of pressure, supporting them. Giving them space and giving them understanding, helping them to manage their times as early as in grade 10. When they get to grade 12, they will now be excelling in time management. They will now be excelling in doing a whole lot of things and knowing exactly. They will now not have first choice, second choice, third choice. They will be saying, yes, I know this is what I want to do. But if I fall back, my personality says this, then after going through that exercise also, which you are still going to be getting through. Finally, I would like to thank the Mpumalanga Department of Education. As the Social Foundation, we are really committed in supporting the district. And our ears are always open. We are solution-based. We don't prescribe headache pills for stomach ache. No, we don't do that. We close the gaps, understanding your challenges, and become as supportive as we can. When we close the gaps, we direct you to the right direction. We bring those solutions to the district and co-create those solutions. And to Osizweni, our implementing partner, and all participating schools, we would like to thank you for the collaboration in making this program possible. Together, we are investing in the future of our learners, strengthening our communities, and building the STEM talent South Africa needs. So all I would like to say, go out there, listen, plan, and do as you are requested to do, and participate. Thank you very much.
Thank you, girls. Ausumpula has reminded me of quite a few things. Ausi Ukaina Mamnyoko I want to bat out Savaka when Ausi come close. Ausumpula was talking about having passion. This lady standing here is working for Social Foundation. She's a chemical engineer by profession, but she's studying towards teaching now. She's now studying to be a teacher, part-time, because she says the head teacher said to her, no, you can't be a teacher, you must be an engineer. And she followed that. But her heart said, you are a teacher. So she went and qualified as a chemical engineer. We are working her in the space now, and you will see her, we will be visiting her with you, and she will be telling you her story. Thank you, As. Mr. Matotsela is disappointing me because Mr. Matotsela is also my DJ. I wanted us to dance for 1 minute. Now my DJ is nowhere to be seen, and they are getting me. Maybe I must get a substitute to another Matotsela. Please come. Just put some music first, I know, and then get you want to get ready with. Please. In December, Bazaling in Kotla, I'm saying a break and Jemo Sisu. Olokanga Zatabang to Kufiga umfane ngamfundisa ngo 1992. Ngo December lengzuleko. Fika umfana ngamfundisa ngo-1992 uyi-structural engineer usekuruleni. Ufika umphethe ungitshela ukuthi to be a teacher you just keep on eating. So I'm just trying to recruit people who will also join us. You know, if you are a teacher, you sometimes meet students who just say, "Menya, do you want cold drink?" And you cold drink wakhona ushibanga, Coca-Cola yakhona 200 rand. It's nice to be a teacher. So please think also of becoming a teacher. Afterwards, I'll ask Mr. Shoba to introduce our district director. Mr. Matanza is coming with tables. Let me assist. I don't know what the tables are for. Maybe it's more food. Put music, Mr. Matanza, once we're waiting for you. It's connected. One of my jobs is to help people wear white clothes.
Are you guys good? Yes. Okay. Sorry to delay. I was running for my life. Okay. September. I think he can assist with the call. Am I audible? Even when I'm using my teaching voice, my preaching voice. Okay, just 3 minutes. I want to set up, then we're going to enjoy this. If you find a way that you did not enjoy this, then I'm not a scientist. Can you hear me now? Yes. That was part of the show. And that was planned. Okay, if this thing fails, then I'm gonna have to use my voice. Okay. I don't know what causes the echo. Okay. We can't. I'm not giving up, I'm just using an alternative. Ne? Please don't give up. Oh, no. Okay. Okay, now let us start with mathematics. I guess I'm audible at the back there. Let us start with mathematics. What I like about mathematics is something that does not exist here. I'm sorry to mathematician. Have you ever seen one in your life? Like number one, one, whoa. What about two? Huh? I'm not talking about writing or whatever. I'm trying to prove a point that mathematics does not exist. You can't touch it, okay? Yes. But you can make sense of it. Makes sense, right? Yes. Now I'm standing before you. By the way, I'm Mr. Matonsela, Sanbona. Yes. Very good morning. Now, I have a capacity to make you say yes. Do you disagree? You just said it. Okay, by the way, what is nice about a show is that the person standing before you can read your brain. Now that you guys are using cell phones and stuff, I want us to make some calculation, but let us make it light so that you can process those mathematic don't in your brain. Is that clear? Yes. I want you to think of a number less than 5 or less than 10. Don't tell me that number. You have the number, right? Yes. You have it? Yes. Are you sure? Yes. I'm challenging the dignitaries to join us. I don't want to see learners laughing alone. Okay. Now that you have the number right, that number it's called Osizweni, right? Okay. I'm hoping that you guys are gonna remember that number. Now with that number, I want you to add 3. Don't tell me the answer. Don't even be tempted to tell me the answer. I said add what? You know the answer, right? Yes. Okay, now add 4. If it takes you to take off your shoes, then it's fine. Okay. Did you add the 4? Yes. Sure. Yes. Now I want you to add 1. Did you add 1? Yes. Okay, it's fine. You know the answer, right? Now, what I want you guys to do, I want you to minus the number so-called Osizweni. Do you remember that number? Yes. Minus that number will tell you answer. Breathe in, out. Before I tell you that the answer is 8, we need... I'm getting multiple distractions because I said before. Okay, your answer was? How did I get it? Okay, anyone with the 5 franc coin? Just one 5 franc coin. Just 5 franc coin. I had it. Okay, thank you for the donation. I'm kidding. I just want to explain one of the concept, so-called speed of the light. Can you think of any place in Standerton? We have it right. Now think of any place in Joburg. The question is, how did you get to Joburg? Did you see your thought moving to Joburg? When something travels faster, it's invisible. Is that clear? Now, I'm having a coin here. I'm going to throw this coin from this side. What is this? Left, right, your left. Then this is left, right. All right, it's fine. Now, I will throw this coin like this. It's okay. I'm trying to demonstrate this because the moment I do it, people end up saying, no, chemistry. And you know, my grandmother, my grandfather, by the way, was in physics. One for this Newton first law. What happened? What began my custom Tamil, right? My finger, when she came back, she was like, what was that? Where's the money? Like, what money? The money was here. Move it. Unless first act upon it. Right. Okay, it's fine, let's do it. Having an object traveling slow. Now, if it travels, okay, can you look at beautiful, right? You want me to repeat? Unfortunately, quiz this session, I was going to repeat. Now, the universe listens, is okay, and react. Is okay. Now, we're having this gentleman here, so-called Tong Tong. What's the name of this gentleman? Tong Tong. You instruct Tong Tong by singing. Go down, Tong Tong, go down. Tong Tong will go down. When you say stop, Tong Tong, stop. Tong Tong will stop. When you say go up, Tong Tong, go up. Is that clear? Are you ready to sing? Yes. Show. Yes. Go down, Tong Tong, go down. Let's go. Go down, Tong Tong, go down. Yes. Okay, beautiful, right? Now, okay, it's fine. Let's sing again. Go down, Tong Tong, go down. Go down, Tong Tong, go down. Go down, Tong Tong, go down. Tong Tong is pushing me. Okay, it's fine. Which direction should we go? Shall we go? Are you ready? Yes. But I can't hear the sound from the back. Yes. Okay, let's go. All of us. 1, 2, 1, 2. Go up, Tong Tong, go up. Again. Go up, Tong Tong, go up. Yes. Go up, Tong Tong, go up. Anyone with the pen? With the pen? Okay, I can't hear you, program director. The program director is saying that I should leave. Guys, thank you. Last one. You went that side and say. Okay. Now, is this the pen, right? The material, you cannot bend it, right? But what's fun is that we can. Beautiful, right? You know it? It's beautiful. Remember, you guys are future scientists and engineers. Go and inspire the young ones. Is that here? When you do this, they'll be like, oh, just like dust. Okay, it's fine. Thank you. Oh, you must get a phone. All right. I'm about to do the last one. The universe listens and reacts. It's like here. and act. React. I'm thinking of reactant and product, Mr. Shoba. Okay, it's fine. I just want to make an instant Fanta orange. What color is Fanta orange? Orange. Someone said red. Okay, it's fine. Now, what color is Coke? Red. Something like that. Is that clear? Okay, now I'm gonna have my liquids. Remember that this is an instant Coke. This is sugar, special water, and this is the acid. That one that makes you to say. Okay, it's fine. Let me just pour my sugar. Remember, this thing disappoints. Ne? The moment you leave the house with your brain, like going outside of this hall, like thinking of something else, this thing won't happen. Pay attention. Is that okay? Let's go. Okay. Remember, we're not making a zero sugar, right? Okay. Let's wait. Okay. Solution A. Solution B. Beautiful, right? I wonder what will happen if I can sing that. This is beautiful, right? I'm shaking, guys. Yeah, it started 2019. I've been trying, but okay, thank you for watching me, guys. I thank you. Kanjan much. Okay. Sugar. What is this? Special water. Special water. Okay, now. This is too much. This is too much. But it's fine. Okay, I'm gonna instruct it to Fanta, then Coke. If you blink, you won't see that Fanta. You will only see what? Coke. Let's go. Fanta orange. Physical science program. Any question? Don't ask me difficult question. If I don't know the answer, please pause the camera. Now that she was confident to ask a question, she deserves a... What was the question? Okay, beautiful, right. Remember, this is the show. Zakia, this is the show. It's the element of curiosity. You must be asking yourself, what is happening there? He's lying. I want to prove it myself. Zakia. Then you end up researching and get the actual solution. Zakia. A couple of years back, Professor Wesi performed this experiment. And I asked Prof, what did you mix there? I know, you must find out. I guess I should pass the same answer. No, you must? But to give you a hint, it's a clock reaction. A clock reaction. The reason why it turns black, starch, yeah. Thank you.
Asipinde shayela izandla. We play in science. We have many interesting things. So if you are a scientist, you also have fun. Some things in science are just done for the fun of it and nothing else. I know what I would do for science. Mr. Shoba, please come forward to introduce the district director.
Thank you very much, Program Director. I'm a teacher by profession. And in the house, Professor Weso was my teacher. Mr. Makai said, I've got the beauty of science. We have seen Mr. Madozela doing a fun experiment. Please don't try it at home. Those were chemicals mixed together, they reacted. So don't do your own coke and Fanta and give it to your kids. They will die. Thank you very much. I'm going to introduce a person who's very important in the house. But anyway, good morning. Yeah. Good morning, the teachers, the principals, circuit managers, parents, and most important about our learners. We are today a very important mind back. Project science. We are here, Professor Wesh was saying 180 of you today starting the project until 2028. In 2029, all of you, when ABC announce the results, you must be among the top 10 learners in the district or in the province. This is not for Mahala. They have been paid by Telecom Foundation, by Sasso. He is here. By the way, happy birthday. Thank you very much. Okay, yeah. I'm going to introduce a very important person in the house who is in charge of the whole district, Highveld. Highveld starts from Elukwatini up to the Balisay. We have got 19 circuits in the district. We have got 485 schools in the district. The person is in charge of all those schools and all the circuits. And he's a very busy person most of the time, but today he said he must come here and grace the occasion. He is a teacher by profession. He's a teacher by profession. And why is he a cut lesson? Natasha, I want to mind. Oh, okay. Yeah. In those days, he was a teacher for maths and physical sciences. That's why he has a passion of the two subjects. That's why he is here. And people are saying mathematics is a very difficult subject. Of course it's not a difficult subject, it's a very easy subject. Because you add 1 plus 1 to get 2 without thinking. If you produce coke, you add 2 chemicals, you get coke. Is it difficult? It's not difficult, is it? So all of us in the house, we are all scientists. So let's perform better. So our director in the district is a physical science and a maths person. He studied the maths long time ago when we were not born at that time. But now he is a district director. He is in charge of the district. He sits in meetings at the provincial level. He sits in national level. He sits in meetings with you. Today he is here. Let's clap hands for that. You can tell that we are all important. If the director is in the house, we are all important. It's a Saturday today. He was in Pretoria on Thursday and Friday. And today is here at Secunda. So he makes sure that when there's an event of maths and physical science, he's always there. So let's welcome Mr. Makabula, who is our district director. And let's give a big round of applause. Thank you very much.
Thank you very much, Program Director, Mr. Makai. Sasol Foundation, Mbulai, Prof. Wesi from Osizweni Center, the distinguished guests that are here, officials from the Department of Education. I've also seen one of the subject advisors who's here, with Ms. Fetter. She's there. I want you to see her. Can you stand up? For mathematics, she's here. Batali labakona lana nabantwana lesinabo here today. Our principals, our teachers that are going to assist Labantwana, Abanda in terms of this particular program as it is being launched today. We have our second managers also that are here. And the Mama Laza, from Copenhagen, second, she's also here, to support this particular launch. I'm saying good morning to all of you. Sanbonani. So namhlanje we are saying this marks really a very important milestone for Highveld as a district. We are not only just here to introduce this particular program and just launch it and say, oh, this is just an academic exercise moving forward. But we are also here to provide our powerful commitment OTISH, Department of Education, Nabantwana who are here, to say we are starting a program and a project of a STEM, which is a very important moving forward. But where does this particular program, come from? Sinaga, as the Department of Education, we are very much passionate about this program. Saying in the no subjects which are so easy, the most easiest subjects in the world, mathematics and physical science. So this particular launch and this it will demonstrate to all and sundry Otisha, Nabatani, Labadana, and Labantwana, who are here, to say indeed this is the most easiest subject. It's the most easiest subject because these subjects are vula umnyango. Not only umnyango where we stay, but here in the district, in the province, to South Africa, and in the whole world. So that is why we are saying, as Sibande, in support of this particular launch today, our hashtag is very clear. As the Department of Education and as a district here, we are saying hashtag 93, 50, 30, 10. Just to break it a bit. Our target in terms of metric, in terms of our SCT, is to say we want to achieve 93%. And we are putting that as a minimum. Because we are moving from the premise of saying, Sibabita bonge, bonge bandwana, we are calling them. Sihamba nabo bonge. Level 1, level 2, and level 3 must fall. If therefore you can analyze that plan scientifically and use our mathematics, Uma sisi hashtag level 1, no level 2, no level 3. Gawe, siyamuyisa. Sisho kusakekho umntali lofuna umntwana wakhe. Sifuna bonke abantwana singabatali esikolweni for their future. Sisi all of labantu sibabita bonke, babize bonke, abo bonke. And if therefore we start in terms of foundation phase, we are saying hashtag 100%. Why would we in the lymphatic? Because being supported, but Sasol Foundation and quite a number of other stakeholders. Therefore, our children, our learners in our school, so that humbly we move it. Because these STEM subjects are the gateway. And the gate therefore must provide all the necessary resources and support to them. To Sasol Foundation, saying let's support, let's provide, let's start them there, where rightfully they will choose these particular subjects, also choosing their careers, support them, groom them, show them the way. Which is there, and this subject for that, and the support that is very necessary. Skills. We want people who will be innovators. We want your good selves. Inner areas, as engineers, as doctors, and all technical people who will come and change our situations. Masipala, wherever we're staying, dealing with issues of roads, all those things that are there, and provide the necessary service to our communities. And it is through the STEM subjects that is there. That is why I started with a very Lama subject lawa, batali, sina was saying, alula. But alula lanjalo, akuna the kind of commitment all of us, timing very clear. Children, basemakhaya, the support that will provide them. If langa liyoshona bala ngakacheckanga nabo, kuthi what is it that they ngomsebenzi wabo wesikole, which I have done, because we must ensure that there's time for them to be able to practice emakhaya themselves by Otisha, by this program to do emakhaya. They can't be spending these 24 hours. Bangal divide labantwana these 24 hours to say there's time to play, and there's time for, which means you must have that kind of mentality, even from emakhaya, wherever, but with this necessary support, and do not just pass this burden to Igolo and to these particular programs which are supporting our learners. Also play our, and also encourage them, these learners, to move forward, prosper in their lives going forward. Now, Sasol Foundation Education, we are fully supported coming with. Sibatala basesebancane, simuva nabo. When they get into grade level, growing, and know already that they are opening this with the necessary support to move forward. In grade 12 this year, which must also know to have over 18,000, and out of the 18,000 grade 12 learners, siyabatreka labantwana. We are saying labantwana laba, and to be able to get, we should take them to institutions of higher learning. And today, we want a majority of our learners to take these STEM subjects that are there. But currently, out as a district, but not to that extent, because out of those learners, 7,100 and something of those learners are taking maths. 7,000 out of the 18,000. And 6,000 plus, they are taking physical sciences. We say we are proud because in these 4 districts here in Mpumalanga, with regard to numbers as corresponding, we are far above them. You can check the statistics in grade 12, and the statistics will tell you that we value these 10 subjects. But it's not only if Sasol was not there, if Sasol Foundation was not there also to encourage and support us, would not be having and all of us running around Mr. Masondo and say, let's push, because it's about the future. Yala Bandwana. Here. Spoke about the 24 hours, and I'm saying 24 hours must be divided correctly And your good selves, therefore, as learners, you just have to start now to know and you understand you will be needed to put a bit of commitment in terms from Monday to Monday. Whether it's an hour, whether it's 2 hours, but something about these STEM subjects you must have to practice and just add some figures. Whether you use these subjects and the kind of the work that you must be doing in terms of these particular subjects. Also stand here by our head office to say I must also pass their gratitude here to Sasol Foundation and Osizweni. You are offering, particularly in Highveld. We're supporting that and we're requesting siyanusa ukuthi nibantwana bothisha abantu ababhizi ngalabantwana baphiri ngiyabona send sure because we really support them so that this project is not fail but is to produce the kind of intentions it wants to produce. Thank you very much and thank you once again, Sasol Foundation. We are committing ourselves to support this particular program. Thank you very much.
Spin the shines under for district. Obaba badlayo bazosilekelela sifuna ukuthathela isitendi sisubeke la ngoba i-next speaker would like us to show us the stars. Sizobona ama stars. So we just want to bring the stand up for the next presentation.
session that you don't want to miss. I can promise you, this is one session that you don't want to miss. Don't worry, you are seeing me for the last time here on stage, and I have okay, 2 minutes. I just want to introduce the guest speaker, okay? And I will want you to listen to this introduction very, 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 very carefully, because this is where we want to see you guys in the future. Are you listening? Yes. All right. Now, imagine, are you imagining? Imagine I tell you that science literature refers to him as South Africa's shooting star. Imagine I tell you that at a tender age of 13, he built his own telescope using metal pipes and pairs of lenses. And imagine I tell you that in 1986, he used this home-built telescope to look at the Halley's Comet. Anyone has heard about the Halley's Comet? To observe the Halley's Comet that our solar system in 1986. Imagine I tell you that of the moon. Imagine, I tell you that he became astronomer, the first black astronomer in South Africa. Ladies and gentlemen, boys and girls, he is not only an outstanding academic, he is the deputy dean of the Natural Science Faculty, Natural Science and Agricultural Sciences Faculty at the University of the Northwest. He traveled all the way from the Northwest province, from Mahikeng in particular, to only come talk to you. Ladies and gentlemen, he's not only an academic, a scientist, and an educator. You will be happy to know that he is also a movie star. Now, Professor Midupi starred in a movie slash documentary of 2003, where he featured. If you have not watched it, its name is called Cosmic Africa. If you have not searched it, and if you can find it, you'll be very lucky. I don't know how many times I have watched it. Cosmic Africa. Now, the movie called Cosmic Africa, it's a 2003 movie, features Professor Midupi, his career path, and the African perspective of astronomy. Ladies and gentlemen, let us welcome on stage Professor Midupi as he addresses.
Thank you for that very amazing introduction. Good morning, ladies and gentlemen, boys and girls. You are all here. It's really nice when parents know what that today is a very special, unique kind of arrangement we have. That will see the value of getting to take up, because almost no institution will accept you as maths literacy. Even if you want to do agriculture at our university, we will not accept you if you do not have maths, normal mathematics, or what I call pure mathematics, and physics, and the sciences, basically. So really, if you are choosing maths literacy, you are going on a road to nowhere. So really, 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 do not take that. I mean, with maths and science, you can even become a lawyer, you know? That's how much it opens up opportunities for you. So really, if there's any message you can get from today, it is that you should do pure mathematics. Although it's hard, we know why people are taking maths literacy, but sometimes you have to face hard things head on. Okay? So please, pure maths. You can become an engineer, you can become a data analyst, you can work with big data, you can build computers, you can program computers, you can write all these fancy technological things that are happening today. So anyway, thank you, Dr. Wesi, for that introduction. So I'm just like you. I was a child just like you at some point. I was born in a village outside a small town. The town has become a little bit bigger now, but it was a very small town when I was growing up in the 1980s. It was a village. We had to go and get water from a pompo. There was not even electricity in the middle of the 1980s. So I come from the same background as some of you, or probably most of you. But what made my life, what made me follow the path that I followed, is that I had very good teachers. who really used to have an interest and show me what to do, you know, and have developed an interest in what I was doing. For example, when Halley's Comet came in 1986, I was 13 years old. The whole school, my school, organized a theme for the whole month on astronomy. So all the subjects, whether they were mathematics, they were English or Setswana or whatever, they talked about planets, they talked about the solar system, they talked about, you know, things up there, stars. And obviously as a child I caught on, and I went to a library. We had a public library where I found books on astronomy, and I found books on how to build a telescope. I didn't invent it. A telescope was invented 400 years ago by Galileo. But I found these notes on how to build a telescope, got all the materials together and built myself a telescope. And of course, as a result, people in my village thought I was mad, because at night, when children were told go and sleep, I'll be sitting out there with my telescope looking at the moon. Look at where it brought me now. So it's really great. And again, it's a message to parents, you know, allow children to explore. Science is very important. I'll tell you why science is important. All the top performing countries in the world that have technology, that have strong militaries, that have strong education, strong science systems, are countries that have invested in science. Because science is about creating knowledge. Once you have knowledge, then you know how to do things. You can build things. So science is about creating knowledge. Engineering is about turning that knowledge into goods, into things that you can enjoy, into cell phones, cars, aeroplanes, and all of those things. So there's a link there between science and engineering. If a country is strong in science, it means it can create new knowledge to solve problems that they have or that other people can have. And once you know you are able to solve other people's problems, you can make money out of it. You can sell your skills to other people. You can sell your products through engineering to other people. And of course, you can even develop systems like agriculture. I mean, today people are talking about drones in agriculture. We're no longer, you know, going around spraying things, walking on feet. You can buy a drone and it can go all over your farm to help you with spraying weed and things like that. So that's why science is important. But I'm encouraging you, really do not take maths literacy. It takes you on a road to nowhere. Okay, so because I built my telescope, I started having an interest in science. When other kids were going home, every day after school I would go to the library and read about things. I mean, I remember when I was doing grade 8, my very good maths teacher was teaching me geometry. He was telling me the sum of the interior angles of a triangle is 180. I stood up and I said, not always. And she thought I was mad. I'm sure maths teachers, I hope you know what I mean. On a flat space, the total sum of those angles is 180, but on a curved space, like a ball, they do not always add up to 180. So where did I get it? I had read about it. They didn't know. They thought I was clever, but it became so natural. You know, I became a bookworm now, especially on science, on mathematics. Yeah, so I became so good in those subjects that I won the Science Olympiad in 1990 when I was finishing my matric. And because I won the Science Olympiad, for the first time, they put me on an aeroplane, they took me to London to participate in a youth international event. But remember, I'm just like each one of you. There's nothing special about me. It just shows hard work, dedication. Once you start something, you don't let go. Follow your dreams, but don't go for the easiest route. The easiest route is maths literacy. Okay? You are not going to get things simple. And just because somebody has been kind of successful, it doesn't mean that they were always successful all their lives. Sometimes there are failures, but because you don't give up, you turn those failures into success. I mean, when I went to university my first year, so from my high school, because of my good marks, I went straight to University of Cape Town. And back then it was very hard for black South Africans to get admitted there. So I went there, and the first day was tough. So when I arrived at the university, because they were telling me at school that this guy is smart, they even used to call me Einstein, you know, at high school. But because I thought I was Einstein, I just said I did not study. Oh, come to results. Hey, I wanted to die. I remember telling my mother after my first day of July results that I don't want to go back to the university. And she said, over my dead body. So look at what it has led to. So I'm telling you my life story so that really, believe me, I'm made from the same cloth, same material as you, same ethnic group. I mean, I know we speak Zulu, I speak Tswana, but we are the same actually. Very, very same. South Africans, similar conditions. You can make it, and you can make it very, very successfully. Okay? Yeah. Now I see the slides are there. So I think a lot of these things have been said. So I'm just gonna, that's my telescope there that I built when I was a boy, when I was 13. And they turned that into a movie, into a documentary called Cosmic Africa. Okay? And that is me there with my telescope looking at the moon. And as Dr. Wezi said, I mean, I was able to see, I looked at, among the things I did was to look at Jupiter, and I saw the 4 Galilean moons. Why are they called Galilean moons? They're called Galilean because the first person to ever see them was an Italian scientist 400 years ago called Galileo. Okay? And Jupiter has many, many moons, unlike the Earth. The Earth has only one, as you know. I talked about my trip to England, and those are all the qualifications that I have. And you think, hey, okay, let me shock you even more. So to do a BSc degree, you have to, it's a 3-year degree in science. Then you do 1 year of honors. So I did my BSc, and I majored in physics and applied mathematics. Very important. Mathematics, applied mathematics, very important because you're allowed to model systems, solve your mathematics, and that mathematics can inform the science you are trying to study about an object. And then I did my honors in nuclear physics. Okay, and then I did my master's in astronomy, and I passed with cum laude, a boy from a village. If I did it, why can't you did it? All right, and then I did my PhD at the University of Cape Town. All of this I did at the University of Cape Town. And because science is fun, and really that's why you must do it. We get to travel around the world. I mean, I did my PhD, up to master's, I did everything at UCT. And then for my PhD, I had an arrangement where 1 year I was spending in Denmark, in Europe, and 1 year in South Africa, and 1 year in Denmark. So I spent 2 years of my PhD studies in Denmark. And really, really great experience. You make networks, you make friends, you learn amazing things, you become great through interacting with other scientists and other people around the world. So all of this is possible, really, really, really. Okay, and then I wanted to show you astronomy now because that is the kind of things that I do. Can I open this one? The kind of things now. Let me be a nerd now. Let me do some nerd. So I went to Mahikeng back to our university. So I became a lecturer in Cape Town at UCT when I finished my PhD. I became a lecturer for 10 years. Then I went back to Mahikeng and I said, I can do the same thing that I do in Cape Town and Mahikeng. And that's what I did. I developed an astrophysics group, and we built, with my inspiration, we built an observatory in Mahikeng, so we have a place where you can go and observe the stars and galaxies and things, which I'll show you now. That's the latest telescope we have now. We've put another one in one of our farms, and I'll show you the pictures that we took with it. That's another more picture of the telescope. So the telescope is like a big bucket that collects light. If you want to collect more light so that you can see detail, you need a bigger bucket, and that's why South Africa has SALT, the Southern African Large Telescope, one of the largest telescopes, optical telescopes in the world. So yeah, astronomers are always going for bigger telescopes. So, and then we also take little telescopes around to show children and parents and teachers around the country. Now let me start the native part now. Let me tell you about my field, okay, what I do. I study stars. I study physics and mathematics of stars. Okay, so physics and mathematics, you can't separate them. You can't tell me you are good in physics and you are bad in mathematics. It's not possible. For you to be good in physics, you have to have good mathematics, because physics is coded in mathematics. And all science is not just physics. Chemistry, even biological systems now, is coded in mathematics. You cannot survive without mathematics. Okay, so let me tell you what a star is. So generally stars are giant balls of gas. So imagine a ball. This is a ball here. Can you see this whole thing here? That's a ball, a transparent ball. Inside are blue beads. So each of these is a little bead. You know a bead? So let me tell you how big stars are. So imagine that this big transparent ball is the sun. Those little beads are the earth. Imagine how big the earth is, right? You can put 1.3 million earths inside the sun. 1.3. That's how big the sun is compared to the earth. And you can also put quite a number of thousands of Jupiters inside the sun also. The sun is a star, even though it's a star that you can see during the day. And the reason you can see it during the day, it doesn't look like a point like other stars, is because it's the nearest star to us. It's very close and very bright, but not bright. I'll show you again in the next slide. It's not the brightest star known, or the biggest star known, or the smallest star known. It's just a normal average star. But it's important to us because without the sun, there's no life, right? Yes. It's winter now, eh? If there were clouds there for a number of days, you feel the cold. So we need light, we need heat, we are where we are because of the sun. Let me tell you something. If I were to cut myself or cut you, take a piece of you, put it under a microscope and study the elements that make you up, what am I going to find? Oxygen, right? Nitrogen, hydrogen, right? You know those elements. They are the elements of the periodic table, isn't it? Yes. Now let me tell you that astronomers, through using physics and mathematics, we can tell you where this periodic table comes from. We believe the whole universe, anything you can see around, you can think of, okay, is part of the universe. We believe that it was created 14 billion years ago through a process called the Big Bang. And the reason why we know that the Big Bang existed is because if you take a telescope, you look at galaxies all around the sky, you see that they're all moving away from us and from each other. So that means that the universe is expanding, right? The universe is going like this, it's expanding. If you imagine this is the universe, it's expanding. So if you imagine that this is a movie and you're watching this universe expanding, you pause that movie, you play it in reverse. You go back in time. So it means, and if you go back enough in time, you reach a point where the universe was a single point. And that is what we call the Big Bang, and it happened 14 billion years ago. At the time when the Big Bang, which created everything, including us, at the time when the Big Bang happened, 14 billion years ago, there were only 3 elements that it created: hydrogen, helium, and lithium. Anything else, oxygen, iron, everything, was not created by the universe, by the Big Bang. It was created by stars. Stars change things. Our sun is taking hydrogen, converting it into helium, producing energy in the process. Eventually, hydrogen will be finished. There will be only helium left. Then it will convert helium into carbon and oxygen. That's how that's how all the elements of the periodic table were created, by stars, except those 3 that I mentioned. Anyway, so I'm getting more technical. I hope you understand me. I hope but yeah, and then let me demonstrate the size of things with that picture there. So here are the 3 inner planets of the solar system. This is Mercury, Mars, Venus, Earth. Of those 4 inner planets, the Earth is the largest, okay, slightly larger than Venus. this is the relative sizes, how they, in size, how they look to each other. So the Earth is bigger than this, it's much bigger than Mars, it's much bigger than Mercury. But if you were to place our Earth next to the outer planets like Jupiter, Uranus, Saturn, and so on, you see how small our Earth is, right? Now, and you think Jupiter is big. If you now take Jupiter and compare it to sizes of stars, there is Jupiter, there is one of the smallest stars known, it's called Wolf 359. There is our sun. So the Jupiter is much smaller than the sun I showed you before. And then our sun is smaller than the brightest star known or seen from the Earth. The name of that star is called Sirius. So our sun is smaller than Sirius, and there is Sirius in this part here. And you see that there are stars that are much, much bigger than Sirius, and therefore much bigger than the sun. And then the biggest star in this group is called Aldebaran. If you take Aldebaran and compare it with other very large known stars, you can see that stars come in different sizes. Some of them are extremely big, some of them are small, like this Wolf 359. So stars come in different sizes, and but nonetheless they are still very, very large. And then let me show you this one. Also, this is also stars come in different colors. If you go outside at night, you see definitely that there are some red stars, blue stars, white stars, and all those colors indicate how hot those stars are. Blue stars are very hot, red stars are much cooler. But again, hot, what is hot? Our sun is a G star. The surface temperature, remember it's a ball, so the surface temperature of the sun is 6,000 degrees. That's how hot it is, 6,000. If you go deep inside the sun to the center, the temperature is 15 million degrees. So stars are very hot. Okay, so the different colors of stars, they tell you the different temperatures. And then I'm not gonna go through this one, it's too complicated, a lot of writing and so on. But basically stars have a life cycle like human beings do. You know, they are born from a cloud of gas, they burn hydrogen into helium, they become giants, and eventually they explode as a planetary nebula, and what is left is what is called a white dwarf. That's just an example of what our sun will become 5 billion years from now. So, so imagine this is the sun now. In the future, it's going to become like that. Where will the Earth be? Swallowed up. So nothing lasts forever. Eh? But you should not worry, because this will happen 5 billion years from now. Where will you and me be? So, for your lifetime and my lifetime, your great-grandchildren's lifetime, the sun will look the same. Don't worry. Okay, and then let me show you about these places. So this is a picture taken with our telescope, Mahican telescope. I took it myself, and I'm comparing with the picture of the same object. It's called Orion Nebula. These are clouds of hydrogen gas and dust floating there in space far away. And these stars here, you see these 4 stars? They are there. Those 4 stars were born from inside the cloud. So we see these things, and that's why, these are measured things and calculated things. We can model them using mathematics and physics, and we know they exist. But you can see that, even with our telescope that we put together, as in Mahican, we can measure these things from there. So you also can do it, eh? Everyone can do it. Let me show you another example. This nebula is called the Dumbbell Nebula, and this is really this one like that into what is called a planetary nebula. That is how our sun will look like maybe 5 billion years from now. And then okay, now let me end there. There's too much. Oh, let me show you this picture. This is a picture we took with our telescope of the moon. The moon looks like the Earth. Right? These are rocks. This thing here is called a crater. The crater happens when a very massive rock falls from space, hits the surface, and digs a hole. So this hole is called a crater. The distance from there to there is 100 kilometers. This crater is called Plato, and we took it with our telescope. So really, this is real. You can all come in and enjoy it. Okay, I think I have said enough. Maybe you can ask, I mean, these are other pictures of tubular telescope of groups of stars, stars, all of that. So, thank you very much. I will be happy for questions.
Anyone has a question for Prof? Anyone has a question? There's a question, come forward. Come.
Can be translated, or I might understand you.
So, I have a question about concerning the Big Bang. So y'all believe that everything just happened. I know the Big Bang, but if you look at Newton's law, first thing about the Newton's law is that thing moves if it's pushed. And general information is that when something is created, nothing never comes like on its own. Something has to be created. So why do you all believe like in the Big Bang necessarily? Which like everything is based on the Big Bang. A building is a proof of a builder, and a painting is a proof of a painter. And if you look at how the
rain,
if you look at how the earth evolves,
the rain, who's the builder of the rain?
I will get to that. We'll get to that.
I understand that. Hey, this is exciting, huh? Wonderful. Hey, you it's challenging me now. So I hear what you are saying, right? I think you are trying to tell us that this leads to the existence of God. And I'm not going to dispute that, but I'm also going to ask that there's philosophical problems with that argument. Who built the builder?
Who built the builder?
If something has to be built, who built the builder? And who built the one who built the builder and who built? So you go back, you go in a loop, you go in an infinite loop, yeah.
I have an answer for that.
Okay.
Alright. For me to build a building, I have to be outside the building. I mean, for me to build time, all the concept of time, space, and matter, I have to be outside of that. Me and you are in the concept of Uguti, there is time, there is space, and there is matter. And it necessarily us believing in God, it means that yes, well, God is outside the concept of space, time, and matter, and making him God. Me and you are affected by space, time, and matter. That's why we believe Uguti, there has to be a builder to build a builder consecutively. So
ladies and gentlemen, this is wonderful. I mean, I'm impressed that you're thinking. But we risk mixing things. We risk, I mean, there is a realm of religion which nobody disputes. No scientist will tell you religion, will argue against religion, because religion is outside of science. Science is physical, okay? We note, we report on what we see. And if I tell you that there is a cloud there, you come and check that there is a cloud. Don't just believe me. That's how we do it. So, we have never seen God with our instruments. But I'm not going to say he doesn't exist, but we haven't seen him. But I'll be telling the truth too, right? We have not seen him. So, as scientists in science, you are happy in reporting what you observe, correcting it, showing that it works, developing materials with it. Those issues about God, we leave it to people, to religion. It really is outside science. And it is possible that you can believe in God and be religious and be a scientist as well. I mean, there are well-known top scientists who were Christians or who were religious people. I mean, Isaac Newton was a Christian, the most famous, the most brilliant physicist. So I think let us not mix the two.
no, I'm not coming.
And also, don't get trapped into saying, because I don't know now, therefore, it's everything that you can explain, you say it's God.
No.
Then science doesn't even develop in that way. You keep on questioning until you come to the answer. But I'm not here to say that God doesn't exist already. I mean, I cannot, my instruments do not allow me to say that.
No, if you look at logic, besides God, if you look at logic says, somebody created this. Somebody created this. And if we can look at evolution.
So let me give you what logic tells me. Logic tells me that I cannot go through this thing. Right? I'll bounce back. That's what scientists used to think until quantum mechanics was developed, where you see particles sometimes going through the walls. What is logic?
Okay.
I want to. What's your name? Yes, this is an Israeli from Sizwagele. A big hand to Sizwagele. And one thing this discussion demonstrates about science really gets deep into philosophical matters, into religious matters, but in science we have got a way in how we think. And all the time, some of the ways we have been thinking, we have also adapted them. Because at some point we have come across scientific proof that says what you were thinking was not right. So science is always evolving, and it wants people who engage like you do. Well done, our scientist.
Well done.
One more question?
There is after him, I want to be asked by a girl.
We wanted a girl. Okay, if girls are shy, we can't do anything. Where is the girl?
Yeah, please. Go ahead. Okay. Here. Talk to the mic.
I was asking, how did you know, the sun is going to do something in 5 million years?
Woo! Very good one. How do I do?
How did you know? There were cameras during then?
No, they were not. But that's a very good question. Let me tell you, man. Imagine an alien coming to Earth, walking into this room, trying to understand human beings. They are seeing young human beings like you, they see middle-aged human beings like that, they see old human beings. And the job of that alien is to form a story. So if you point at stars, you see different young stars, old stars, and so on. You use physics and mathematics to join the dots. That's really, so you don't have to go to the sun and stick your finger there to know that it's 6,000 degrees. I mean, in fact, even with laboratories on Earth, you can use how do you measure temperatures of things in a laboratory without using a thermometer? I mean, the thermometer, as you see, you stick it inside, you can measure the temperature. But how do mining engineers measure the temperature of the kiln? They use physics. And it works. They use physics and mathematics. They model the system. From the modeling, they can determine the temperature. But think of that analogy I gave you, that if an alien walks into this room, if they are a smart alien and they use mathematics and logic as somebody was saying earlier, they'll be able to say that these are all human beings at different stages of their lives. So that's how we're able to determine the different stages of stars, by looking at the different ones, the old ones and the young ones and the dying ones and the dead ones. And we know, and we see patterns. We see that the behavior depends on how massive the stars are. Yeah. Measuring with a telescope. The telescope gives you the measurement. The mathematics gives the modeling. and you compare the measurements with the models, and you can tell how hot things are, how far they are, and you can even tell. Remember how I told you that we imagine the universe, how we imagine the Big Bang happened. Remember what I said? I said, you look at the universe now, you look at the different galaxies, faraway galaxies all over the sky, and they all seem to be moving away, because there's a way of measuring whether they're moving towards you or moving away. And so somebody imagined, said, imagine that this is the universe expanding like this. I mean, this is a movie, right? It's in time, changing in time. If you stop that movie and you play backwards in time, it means that the past the universe was smaller and smaller and smaller until it must have been time zero where the Big Bang happened.
There's a question here. He's asking about tectonic plates.
Oh, on Earth?
Yes, on Earth. And how do you know that they are moving away from each other?
Oh, yes. So, yeah, very good. So again, you don't have to go down and see those tectonics, although sometimes you see them. For example, the Great Rift Valley in Africa, you can see that it's becoming wider and wider. And there's a belief, scientific belief, that in the future, that part where the Rift Valley is will branch away from Africa and become an island or something like that. But scientists use sound waves. It's called seismology. They send sound waves through the earth, and by measuring the physics of the sound, they can determine the different rocks and the different things that are down there, further deep in there. And by studying, observing how these sound waves react to those, they can build a map of what is going on under the earth.
Okay.
I do the same with stars, and we use sound waves that are generated in stars to determine the physics of stars.
Okay, thank you. I'm going to give them a prize. Let's clap for them. Mr. Anderson, you owe them a prize. There was a lady, a girl. Is there a girl? Okay, guys, we'll talk later. Because of
I think
time.
you must give a prize to the first one too.
Yes, I'm going to give a prize to them. Yes. No, come, my girl. One thing we must be clear about, scientific questions cannot be answered in a minute. We need to be clear. If you are a scientist, you must be prepared for the rest of your life to answer a question.
Hello.
Hi, how are you?
Good evening.
So my question is, why was Pluto cancelled as a planet?
Aha, very good question. And again, I'm going to take into about me. So this was 2006. We had a big conference of astronomers. I think it was in Czech Republic, Europe.